All right, welcome back to the deep dive. Today we're going to get into something that's pretty crucial for all you bow hunters out there.
Yeah, absolutely.
Doesn't matter if you're just getting started or if you've been at it for years and years.
Yeah.
We're talking about broadhead performance,
Yeah.
specifically how different broadhead tips perform when they hit bone. And we're really fortunate today. You guys sent in some incredibly detailed research for us to kind of dig into. So our goal today is to really unpack that, focusing on what matters most for ethical, effective shots out in the field.
Exactly. We're going to be diving deep on the 2005 UP Date Part 1 tip design document. It's from a pretty comprehensive arrow lethality study, primarily focusing on Asian buffalo. One of the things that is immediately apparent is the amount of data that they have. They have over 450 primary shot records on Asian buffalo, and each one of those records has over 100 data points. They also have a bunch of broadhead and chronograph data. So there's a lot to unpack here.
Yeah, 450 shot records. That's a ton of data.
Yeah.
So this update specifically focuses on the design of the broadhead tip.
Yeah.
And I know some folks listening might be thinking, okay, well, buffalo, what does that have to do with the deer that I hunt?
Right.
And it's a fair question, but think of it this way.
Yeah.
If a broadhead tip can handle the thick bone of a big, tough animal like a buffalo,
Yeah.
you can bet it'll handle the bone of any big game animal, including, white-tailed deer that so many folks pursue.
Right.
So the core of what we're going to talk about today is what does this in-depth research tell us about how these broadhead tips perform against bone?
Yeah.
How can you, as the bow hunter, apply that knowledge to your arrow setup, your shot selection,
Right. Yeah.
and have better outcomes in the field?
To understand that, we need to get a little clarity on some of the terms that are used in this document. They're very specific with their with the way that they use the language. So when they talk about penetration, they define it as penetration is defined as the depth of the wound channel within the tissue.
Okay.
But here's a key point when you're comparing arrow setups. The document states, it should be noted that all shots are recorded. However, when formally comparing penetration between different arrow setups, only those shots stopping within the animal can be used.
Okay.
Once an arrow shows an exit, the medium has changed. The arrow is no longer penetrating buffalo, it is penetrating air.
So it's not an apples-to-apples comparison if one went through and one stayed in, basically.
Right, exactly. So to have a good comparison of how well the different setups penetrated, they had to look at the arrows that stayed in the animal.
Gotcha. So pass-throughs, in this case, aren't useful data points. It's strictly how far it goes in the animal, not whether it went through.
Right. And then there's another term. They talk about penetrated, meaning complete passage of the broadhead and or the entire arrow through a structure, i.e. rib or scapula.
Okay.
And again, they're very specific. They say, for a rib or scapula to be penetrated, the entire broadhead or arrow must pass completely through the bone. The tip of a broadhead protruding out the backside of a bone does not constitute penetration of the bone. The bone stopped the broadhead arrow's penetration. It did not penetrate through the bone. So, having the tip stick out isn't considered, penetrating the bone itself.
Right. So it's got to go all the way. Just touching the back isn't enough.
Exactly.
Gotcha. Now, they talk about kinetic energy and momentum.
Yeah.
And this is a key point, to keep in mind. They emphasize the kinetic energy and measurements referred to throughout the updates are the levels at impact, not those as the arrow leaves the bow.
Right.
So all of the energy momentum figures, those are at the point that arrow strikes the buffalo.
Right. Exactly.
Gotcha. So now that we've kind of got those terms ironed out,
Yep.
let's talk about the tests, how they actually tested these broadhead tip designs against the bone of these buffaloes.
Yeah. So their first major test, what they refer to as a focal study, was designed specifically to see how different broadhead tip designs affected both the broadhead's ability to withstand impact, the durability of the broadhead, and its effectiveness in penetrating hard tissue, meaning bone. So for this, they chose Tesker-conquered broadheads. And this is a key point The study mentions that in earlier buffalo tests, using the same arrow setup and bow tested here, the Concord had shown a tendency to bend frequently.
Well
They're
done.
not highlighting a flaw in the current batch.
Right.
They're just saying they deliberately used a broadhead that had shown a weakness,
Gotcha.
and how that weakness could be overcome
Okay.
by the different tip designs when hitting bone.
So they wanted a broadhead they knew might be susceptible to bending
Right.
to really test the tip designs.
Exactly.
Gotcha. Okay. And what were the tip designs that they tested?
So they examined 7 distinct tip profiles. They started with 6 broadheads featuring the standard factory needle tip.
Okay.
And then they had 6 broadheads of each of these. Flat, meaning the tip was squared off. Chisel-shaped, arch-shaped, round, tanto, and a COI, which stands for cut-on impact, concave tip.
Okay.
And a key point, as the document states, is that all tip designs except the flat tip were sharpened to be cut on contact.
Gotcha. So most of them are designed to start cutting right away.
Exactly.
Okay. What about the sharpness, the cutting edges?
Right. Well, they were, really careful to make sure everything was consistent.
Okay.
They stated broadhead edges were sharpened with a double bevel of 25 degrees for a 50-degree total sharpening angle, with edges honed and stropped to a true shaving edge.
Okay.
So they made sure that all the broadheads were sharpened to the same level of sharpness.
Gotcha. So that eliminates any variable there.
Exactly, yeah. And then they also make sure that the weight of the arrows was very consistent.
Okay.
They said that the average and the median arrow mass were 771 grains for all 42 arrows.
Okay.
And they had a tolerance of just 7.5 grains.
So that's pretty impressive attention to detail there.
Yeah.
What was the setup for actually, shooting the arrows?
Right. So to make sure they were hitting the scapular flats, that's that relatively flat part of the shoulder blade,
What?
they conducted the shots at 10 yards.
Yeah.
And they used a long bow with a 70-pound draw weight.
Okay.
And the study states the arrow's average impact momentum, MO, was 0.442 slug a foot second. Average impact kinetic energy, KE, was 28.48 foot-pounds.
Right.
And they chose to use this lower impact force, as they explain in the document,
Okay.
so that most of the broadheads would be unlikely to penetrate the scapula flat.
Gotcha.
And that was key to really seeing which of the tip designs were most effective at initiating and
Yeah.
continuing penetration
Right.
on a tough bone surface.
Right. So they weren't going for, blowing through the bone. They wanted to see
Right.
under similar conditions which tips performed the best.
Exactly.
Okay. Now they tested each of these 7 designs on multiple animals, right?
Yes. So they utilized both scapular flats of each buffalo, which meant that every tip design was tested by firing shots into the scapular flats, with all 7 tip designs tested on each buffalo.
Okay.
And then they also included another important test. The document mentions on each buffalo, 3 shots were fired quartering from the front, giving a sharply oblique 40-degree angle of impact on the bone.
Okay.
And that simulates a common shot angle that
Right.
bow hunters face.
Yeah. And one that can be, really tricky depending on where the arrow hits.
Absolutely.
Okay. So they had a really well-designed testing process.
Yep.
What were some of the most significant findings? Like, how did these different tip profiles actually perform?
Well, they found that the document states cut-on impact tips with round or tanto profiles show a marked increase in bone penetration and a low frequency of damage.
So round and tanto are looking good right off the bat here.
Yeah, they're the top performers when it comes to bone. So for you, the listener, the key takeaway here is that cut-on contact tips with either a round or a tanto profile were significantly better at getting through bone, and they were less likely to be damaged in the process.
Okay. And what about some of the other tip designs they tested?
Yeah. So the other designs were less impressive. The document clearly states no broadhead with a flat, chisel, or concave configuration penetrated the scapular flat.
Okay. So they just flat out didn't work.
0 successful penetrations for those 3 designs.
Wow. Okay.
And then the needle-tipped broadheads, they also struggled. They found that they had a low frequency of penetrating the scapula and a 100% bend rate, reducing the amount of overall penetration on those penetrating the bone.
100% bend rate.
Yeah, so even when a needle tip did manage to get through some bone, it was guaranteed to bend, which hindered its penetration.
Gotcha. So needle tips, not ideal when you might encounter bone.
Yeah, exactly.
Okay. And then what about that arch profile they were looking at?
Yeah. So the arch profile, it It fared only marginally better than the designs that had zero penetration.
Okay.
As they say in the study, it fared only slightly better than the flat, chisel, and concave. So it wasn't a complete failure, but it still wasn't as good as the round and the tanto tips.
Yeah.
But one tip stood out for its toughness.
Okay.
They mentioned that the durability of the Tanto profile was no surprise. In all prior testing, no tip of the Tanto profile has suffered damage.
So not only good at getting through,
Yeah,
but also really tough.
incredibly robust.
Okay. Well, let's talk a little bit more about this Tonto tip because I mean, it's been mentioned a few times. It sounds like it was a real top performer in terms of both penetration and holding up to impact.
Right,
So what exactly is a Tonto tip? Like if I'm, picturing a broadhead,
right.
what am I looking at?
Yeah, that's a great question, and it's one that the researchers themselves got a lot. They included a section specifically to address this. It starts with numerous queries have been received asking what is a Tonto tip and what does it look like.
Okay.
And the explanation's pretty straightforward. The researcher who coined the term explains, I coined the term Tonto tip over a quarter century ago, and I chose it merely because the profile reminded me of two Tonto knives placed back to back.
Okay.
So it's named after the Tonto knife blade.
So it's more about just the shape and how it looks than like
Right.
a specific uh, engineering term or anything?
Exactly.
Yeah.
Yeah, gotcha. And then they go on to say, the Tento tip is a profile that can be applied in any width. Ergo, one can have a narrow Tanto tip, wide Tanto tip, or a Sequoia Tanto tip, such as I changed the Grizzly's factory tip to, or a non-Sequoia Tanto tip, such as the Grizzly's factory tip. The slope of the Tanto tip may also be varied, altering the Tanto tip's mechanical advantage.
Oh.
So the Tanto tip isn't just one specific design.
Right.
It's a profile that can be incorporated into lots of different, broadhead shaped sizes.
Okay.
Even the angle of the tip can be adjusted.
Okay.
And the study also mentions that modifying broadheads that have weaker factory tips
Right.
to a Sequoia Tanto profile completely eliminated tip damage in later tests,
Oh.
even on broadheads that had good blade strength, steel quality. So it really highlights how strong the Tanto tip is.
Yeah. It seems like that Tanto tip profile really shines when it comes to taking a hit and not getting messed up.
Right.
Now they also talk about something called bone skid analysis.
Yeah.
What is that?
So after the arrows impacted the buffalo scapulae, they examined the bones. And they state in the study that the impacted bones were cleaned of all soft tissues and closely inspected to permit examination of the bone surface for evidence of a bone skid and, when present, the degree of skid.
Okay.
And the findings from this analysis were really interesting, especially for that Tonto tip.
Okay.
They say the Tonto tip design showed a dramatically reduced tendency to skid upon bone impact compared with all other tip designs. The Tonto tended to bite into the bone surface better than any of the other tip designs. It began bone penetration sooner after impact and retaining more of the arrow's forward momentum to aid in penetration. This accounts for why the Tonto-tipped broadheads consistently demonstrated the deepest overall penetration.
So that Tonto tip, because it's less likely to kind of glance or deflect off the bone,
Right.
it can transfer more energy into actually,
Exactly.
getting through the bone.
Exactly, yeah, which is a big advantage when you're trying to, make a clean kill.
Exactly.
Yeah.
Now, we've been talking about this study with buffalo, but I mean, this stuff isn't just
Right.
specific to hunting buffalo.
Yeah, right. The study explicitly states this information is applicable to all big game of all sizes, deer, bear, elk, moose, etc.
Okay.
They also state, white-tailed deer have heavy bones. They are the humerus, scapular ridge, spine, femur, pelvic girdle, and skull.
Yeah.
So even though deer are smaller than buffalo, they still have those big bone structures that a broadhead might hit.
Right.
And the principles of penetration, durability,
Yeah.
they remain the same.
Yeah.
So this research is really relevant for anyone out there hunting deer.
Yeah, absolutely. And I mean, those are some pretty, key areas on a deer where a broadhead that's not performing well,
Right.
that could be a real problem. You could get deflection. You could have,
Yeah.
not enough penetration,
Right.
which can lead to a lost animal.
Exactly.
And I think there's another really important point here that they bring up in the study.
Yeah.
It's just something that every bow hunter really has to think about.
Yeah.
That even with a well-placed shot,
Mhm.
things don't always go according to plan.
Yeah, you can't always control what happens out in the field.
Yeah.
The document reminds us, no matter how good a shot you are, as long as arrows travel slower, the speed of sound animals will be able to react to your shot before the arrow arrives. In other words, the animal gets a vote, and this could result in your arrow impacting a heavy bone, even though that is not what you aimed at.
So you might make what you think is a perfect shot, but that animal moves at the last second, and suddenly,
Right. Yeah.
you're hitting bone. You're not hitting where you wanted to.
Yeah, exactly.
So it's a good thing to keep in mind.
Absolutely.
And it kind of plays into the idea of, skip angle,
Right.
especially when you're hunting from, elevated positions like a tree stand.
Exactly. And the study highlights that broadhead skip angle is especially important when shooting at a downward angle, such as from a tree stand. Think of the multi-curved surfaces of the spine and ribs. It is highly likely that your arrow will impact the bone surface at a steep angle, increasing the probability of a bone skid. So, those downward angles that are common when you're hunting from above
Yeah.
can really increase the risk of your broadhead deflecting off the bone.
Right, right.
So you need a broadhead that's going to be able to bite into the bone,
Yeah.
penetrate at those angles.
Yeah.
And again, that tento tip really shines in those situations.
So I guess, taking all of this into account, all of this, this research, this testing, what would you say is the most important, takeaway for our listener here
Mhm.
when they're thinking about their arrow setup, how they're putting their arrows together for bow hunting?
Yeah. Yeah. Well, based on the findings of the study, they conclude that you should design your arrow setup to minimize the odds of having a bone skip and maximize the arrow's penetration potential.
Okay.
And the evidence really suggests that cut-on contact tips,
Yeah.
especially those with round or tanto profiles, offer the best performance
Yeah.
when encountering bone. The tanto tip, with its demonstrated durability,
Yeah.
reduced tendency to skid,
Yeah.
it led to deeper, more reliable penetration.
Right.
And that should be a priority for every bow hunter,
Yeah.
regardless of experience level.
So, I mean, this has been, a really deep dive into
Yeah.
the details of broadhead design, and it seems like, those cut-on contact tips, the rounds, and really the tanto,
You're right.
they're the ones that are gonna, really stand out when it comes to handling bone. That tanto tip's toughness, the way it bites into bone rather than deflecting off. I mean, those seem to be the key to getting, deeper and more consistent penetration, which is really what we're all after, right?
Right. That's what it's all about.
Yeah.
Yeah. And it brings up some, important questions for you, the listener.
Yeah.
Given all this, how might you reevaluate the broadheads you're currently using,
Yeah.
your entire arrow setup?
Right.
Think about the shot angles you might encounter,
Yeah.
the chances of hitting bone.
Right.
What other questions does this raise for you about, getting the best performance out of your arrows
Yeah.
and ensuring that your hunts are ethical?
Right.
So we hope this deep dive has given you some food for thought.
Yeah. Definitely lots to consider. And thanks for diving in with us today.
Absolutely.
We'll see you next time on the deep dive.
See you later.